And this actually confuses a lot of people, because I know what you'd want to think the answer to this is. What's the antiderivative of the ln of x? What is it? That's what everybody says. 1 over x. But that's not true. What is the antiderivative of 1 over x? Ln of x. So this is not quite the same idea. So you're not quite, you kind of follow that? Yeah, so this one's different. So when you see an ln, this is the procedure you're going to follow with antiderivatives and integrals. I actually have 2 pieces here, believe it or not. Do you know what one of the pieces is? Ln of x is one of my pieces. Okay? So this is actually one of my pieces, and what's the second piece? And then dx is the second piece. Okay? So that's why I had to go over this. If I didn't go over this one, you wouldn't have picked up on it. Okay? If you ever have an ln in a problem that's integration by parts, use always the ln part. Okay? So I'm going to say this. I'm going to say u is equal to the ln of x. So what's du? If I say u is ln of x, then du must be 1 over x dx. So you have to get what you get. That is the derivative of the ln of x. You know the derivative, or you should know the derivative. Okay. Now my other piece is what? I always have 2 pieces. You always have a u. Suppose I color code. You always have a u part, and then of course you have the dv part. That's integration by parts. Again, the rule says the integral of u dv is equal to uv minus the ultraviolet, I don't know, minus v du, which sounds like some bad disease of some sort, v du. Okay? And you got to remember it. It's not on a sheet. They don't give you a little formula sheet. You have to understand it. But you practice enough of it, and it's actually, you'll remember it. Ultraviolet minus the integral of v du. All right, so now what's dv? dv we said is equal to the second piece. That's dx. But can you integrate dv? I mean, can you take the integral of dv? Yeah. All right, what's the integral of dv? V, what's the integral of dx? X. Okay? We've had a problem like that, I think, where it was just the integral, I think it was on a worksheet, where it was the integral of dx or something like that. Okay, so now we follow the integration by parts. Okay? What says do u times v, which is this one right here. So this would be x ln of x minus the integral of v, where's my v? My v is x times du. So here's my du that I'm going to put right here. So this would be 1 over x dx. All right, v, and there's the du. Okay. Well, of course, we can simplify a little bit here. Minus the integral of what? Can you simplify this? Yeah, that's just 1. So that's just dx. And so my final answer is x is ln of x minus what's the integral of dx? Yep, and then you got this plus c, and there's your answer. So that actually is the integral of ln of x. Now, how I know that's true? Yeah, if I took the derivative of this, I better get to the same place I started, hopefully. So let's find out. We would say x times, if I'm now doing the derivative, I'm going to go backwards. So 1 over x plus ln of x minus 1, and what's the derivative of c? okay, because c is a constant. So then I end up with, this becomes 1 plus the ln of x minus 1, and so that whole thing becomes the ln of x. Hey, it checked out, okay? I know you want to say, hey, the integral of ln of x is 1 over x, but it's not a reversal of that one. 1 over x is, okay, but not the other way around. Okay? And I have some others, but I think what I'm going to do is, since I have a few days to do this, I'm going to take this in chunks here. I don't want to overload you because there's a couple other changes that you can make that'll be a little bit different. Okay? But I don't want to throw too much at you right away. So I think what I'm going to do is I'm going to stop here. I'm going to circle the ones or tell you the ones that you can try and let you work on them the rest of the time. I think we have till 10 something or another. 10:45. Okay, so we'll give you a little bit.